A tire is round and it is black. However, if you examined all the manufacturing stages, you would realize what a complex product lies beneath its plain exterior. In actual fact, leaving the natural and synthetic rubbers aside, more than 200 different materials are combined to manufacture the tire that we know so well. There is carbon black, silica, and sulfur, plasticizers, vulcanizing agents. But there are also cords, a lot of cords, which in fact can be either steel or fabric such as polyester and Kevlar. These different raw materials are used to produce a wide variety of components. Flat or profile products, steel cord or fabric plies, and also bead wire. These components give the tire its elastic properties, ensure its resistance to wear, provide adhesion, and determine its service life. It all begins on the tire building drum, which is a rotating cylinder with a flexible center so that its edges can be brought closer to each other. You'll see why in a minute. A thin, perfectly airtight sheet of synthetic rubber must first be laid down on the drum. This will act as an inner tube inside the finished tire. The second layer is called the casing ply. Why? Because it contains the framework of parallel fabric cord, which we call the casing. This assembly is the vital substructure and consequently a key component in the radial tire. Set tightly against strips of profiled rubber are two high-resistant steel wire hoops, which are known as the bead wires. They hold the tire firmly on its rim. The casing ply is then folded up over the bead wires to hold them securely in place. Other components are added with the same degree of accuracy. Some tires have dozens of them. But don't worry, we'll not describe them all in detail. However, take a look at the sidewalls. They are made of rubber, both flexible and tough, to protect the tire from side impact. Then, by inflating the central part of the drum, its edges are brought closer to each other. The tire is shaped. The reinforcing tread plies providing directional stability and mechanical resistance have yet to be added. Fine but highly resistant steel cord strengthens these plies. Being laid crosswise to the casing ply, it forms shape-retaining triangles. Now it's time to lay down the tread rubber. It is this part of the tire which will have a tread pattern and will be in contact with the road surface. The unfinished tire is then put into the curing mold, which has all the tire markings and the tread pattern. A curing bladder filled with hot pressurized water forces the rubber back into the mold cavities. The hot water and steam around the mold start the curing process. This curing, or vulcanization, chemically bonds the rubber compounds to the steel and fabric cord reinforcement components. During this chemical reaction, the tire goes from a plastic to an elastic state. Sometime later, the transformation is complete and the tire emerges from its metal shell. The tire has been given its final features and finished shape.
Michelin, a better way forward.